Hello students, in this module I will be talking about the genetic code table, which will give you an idea as to which codon codes for which amino acid. Okay, look, listen and learn. Okay, so let us see what is the genetic code. You already have an idea of it. Now you know that there are four main types of nitrogen bases in RNA, and they are A, U, G and C, correct? Now what is a codon? A codon is a triplet, and this triplet is made up of 3 mRNA bases, correct? So how many possible codons do you think are there? You saw in the previous module there are 4 cubed or 64 possible codons. Now out of these 64 codons, you know that 3 codons are called as stop codons. And which one were they? They were UAA, they were UAG, and they were UGA. These 3 are stop codons. They are also called as nonsense codons because they do not code for any amino acid. But the remaining 61 are called as sense codons because each one of them is going to specifically code for an amino acid. Now let us see with the help of the genetic code table as to which sense codon will code for which amino acid. Let us go ahead and make this table. Okay, so let's understand the idea or the concept of the genetic code table. Now what you see on the top here on the left side is UCAG. Now this will be the first base position, okay? Then on the top, once again, I'm going to put UCAG, correct? And this would be my second base position. Now on the right, I'm going to put 4 sets of UCAG, and this will indicate my third base position. Okay? Now what I'm going to do is I'm going to show you how to fill up this table to get all 64 possible combinations of codons and the amino acids they code for. Let us start with the first case up there on the left top. Now look at that here. How do you fill it? So you start with that first base, which is U, which you take from the first position. You take a U from the second position, and you take a U from the third position, and you fill up the first possibility, which is U, U, U. Now keeping the first and second position same, you take the third position, and there you choose the C, and you fill up the table and you write U, U, C. Similarly, once again keeping the first and the second position same, now we choose A for the third position, and you get the combination of U, U, A. Finally, you take U, U, and then G, and you get the fourth possible combination of the codon. Okay? Similarly, you will basically do what? Is fill up the entire table. Right? Carefully observe the table. Every time you're filling up the table, you're choosing one base from position 1, one base from position 2, and then individually choosing one base each from U, C, A, G at the third position, and you're putting up here all 64 possible codons. And this is the genetic code table. Now let us look at some codons that we already know and must remember forever. You remember AUG? Yes, AUG was the start codon, and it coded for amino acid methionine, represented by 3-letter MET. Now remember, there were 3 stop or nonsense codons that do not code for any amino acid. Which ones were they? You guessed it right. The first one is, there you go, UAA, right there on the top. It's a stop codon. It does not code for any amino acid, so we just write the word stop. Then you have the next one, which is UAG. There you go, another stop codon or nonsense codon. And now you have one more, which is called as UGA, and that's your third stop codon. So you have identified the start codon and all 3 stop or nonsense codons. Now the remaining codons that you see here will code for their respective amino acid, as you can see right here. Okay, I have listed all possible 20 amino acids in these 64 possible combinations of codon. Is that okay? You can also see in this table that some codons code for the same amino acid. And why is so? We'll see that later. Is that okay? Moving on, let us talk about the 21st amino acid. You would say 21st? But I just know of 20 amino acids. Never mind. In the 1900s, early 1900s, A. Bock and his co-workers discovered and suggested the presence of 21st amino acid. The name of this amino acid was selenocysteine. Okay? Now remember, we had a stop codon which is UGA because it does not code for any amino acid. But surprisingly, selenocysteine is coded by UGA. And for selenocysteine, the 3-letter code is SEC. Right? But there is a condition here. Selenocysteine is synthesized only in the presence of selenium, which is an element found in the environment. Otherwise, they say that the standard amino acids for any living cell is only 20. So we can say that there are standard 20 amino acids which are coded by 61 possible sense codons. Because remember, 3 codons were nonsense codons. Is that okay? This brings us to the end of the module where we talked about the genetic code table. In the next module, I'll be talking about the characteristics of genetic code. There are many, so it will be part 1 of the characteristics of genetic code. Thank you and take care.